Hi class! This video is our last lecture for the semester. I know you probably very sad. I am sad too. Please do not forget to register for second Java course, which is COSC 1437. Please register. I will be happy to see you in my class next semester. And today we are going to talk about inheritance. So, what is inheritance? Real-life objects are typically specialized versions of other more general objects. The term insect describes a very general type of creature with numerous characteristics. For example, grasshoppers and bumblebees are insects. They share the general characteristics of an insect. However, they have special characteristics of their own. For example, grasshoppers have a jumping ability, and bumblebees have a stinger. So, grasshoppers and bumblebees are specialized versions of an insect. Let's take a look at this example. Instead of writing and rewriting many different classes, objects with the same fields or the same methods, we can generalize them. We can write one general class or superclass, which we name insect. And this class contains those fields and methods that are shared by all insects. For example, you can see here it's going to be several fields which will fit to both those guys, bumblebee and grasshopper, and same with methods. But also, since they are different guys, we need still to write some specific fields and methods to each of them, to bumblebee and to grasshopper. So bumblebee will contain those fields and methods that's specific to a bumblebee. And grasshopper will contain those fields and methods that are specific to a grasshopper. And again, they have superclass insect where from where they will inherit some common fields and methods. So we can extend the capabilities of a class. Inheritance involves a superclass and a subclass. The superclass is a general class and subclass is a specialized class. The subclass is based on or extended from the superclass. Superclasses are also called base classes, and subclasses are also called derived class. Also, we call superclass parent, and we can call subclass child, and that's the relationship they have, parent and child. Parent again is a superclass with some general information or some common information. And subclass or child class is a derived class from that parent. It has more specific or more like different information, like fields and methods. So the subclass inherits fields and methods from the superclass without any of them being rewritten. So we do not rewrite anything, it's not efficient, we just use what we already have in existing class. New fields and methods may be added to the subclass. So subclass are children, like children classes. And if you have something specific which is not true for both of them, which we cannot generalize, we will write it in subclasses. The Java keyword extends is used on the class header to define the subclass. For example, let me go back. For example, you have insect class, which is general, and when you create bumblebee class, your method or your class header will be public class bumblebee extends insect. And here you can see some similar example, just with different objects. And it's saying public class final exam extends grade activity. And this is example from your book. Let's take a couple different examples of inheritance. For example, here we have class superclass ball, and we have two children classes or derived classes, which is baseball and football. They both balls, but they are different type. They have some different characteristics. And of course, they have something common, that's why we have ball class. The same with pizza. We have pizza class as a super class. And we have pepperoni pizza class and meal lovers pizza class, which are derived by pizza class, from pizza class. So pizza, they have because they are both pizzas, they have obviously something common in, for example, in recipes, but they also have some different characteristics. Next example would be superclass tree and two children classes, orange tree and apple tree. And teacher, superclass teacher and two derived classes, Mrs. Smith and Mr. Brown. They both are teachers. And of course, they have something in common, any fields you can think of. And of course, they have something different, and that's why we have two different classes. Here's another example from your book. The graded activity example. We can see here superclass graded activity, which contains fields and methods that are shared by all graded activities. We can see here private field score, which is using double data type. We can see here three methods, and in this case it's three different get score, get set score, get score, and get grade. And we can see here final exam class, which is a child or inherited class from superclass graded activity. This class contains fields and methods that are specific to the final exam class, inherits all non-private attributes and methods from the grade activity class. We can see here private fields, number of questions, points, number missed, and we can see here some methods. Constructor, get points each, and get num missed. Another important thing to understand is that members of the superclass that are marked private, meaning private fields, right, are not inherited by the subclass, and they exist in memory when the object of the subclass is created, and they may only be accessed from the subclass by public methods of the superclass. So be careful when you create your fields. Be careful with private and public accessors. You need to think. You need to understand. You need to know what you want to do with them. Do you want to inherit them? Do them public. If it's not, it can be private. So members of the superclass that are marked public are inherited by the subclass and may be directly accessed from the subclass. That's what I just told you. If you want to use them from your child class, make them public. And very similar with methods. When an instance of the subclass is created, which means when you create your instance of the child class, the non-private methods of the superclass are available through the subclass object. And you can see here some example. And non-private methods and fields of the superclass are available in the subclass. So what is non-private? It's public, right? And another important thing is that constructors are not inherited. And when a subclass is instantiated, the superclass default constructor is executed first. And here's examples from your book, but I will show you different example. I will show you example with inheritance and with constructors, and of course with superconstructor. The super keyword refers to an object superclass. The superclass constructor can be explicitly called from the subclass by using the super keyword. And just like I told you, I will show you this, don't worry yet. If a parameterized constructor is defined in the superclass, the superclass must provide a no-arg constructor, which means no parameters. Or subclasses must provide a constructor and subclasses must call a superclass constructor. Calls to a superclass constructor must be the first Java statement in the subclass constructor. I know it might be looking confusing, but I first want to explain it to you and then show in the real example. A subclass may have a method with the same signature as a superclass method. So they might have the same signatures. The subclass method overrides the superclass method. This is known as a method overriding. What it actually means? Let's see this example. We have superclass which is graded activity with field score and some methods set score, get score, and get grade. And we have a child class which is subclass and it's named curved activity. It has two fields, raw score and percentage. Also, it has some specialized methods. Constructor, which is curved activity. Get score, which is, you can see the same method signature with superclass. and get row score and get percentage. So this method, which is set, sorry, it was set. This method, which is set score, takes double as a parameter, and it returns nothing, it's void. And they are exactly the same, you can see. Do you remember what method signature is? Parameters, name of the method, and return type. But this method is more specialized version of the setScore method in the superclass. So this is more specialized and we are interested in this. Recall that the method signature consists of the method's name, the data type, methods, parameters in the order that they appear. A subclass method that overrides a superclass method must have the same signature as a superclass method. And we just saw they have exactly the same signature. An object of the subclass invokes the subclass's version of the method, not the superclass. So an object of the subclass uses this method, not superclass method, but this. That's what we call overriding. And subclass method can call the overridden superclass method via the super keyword. And we can see here example super dot set score and some parameters here. There's a distinction between overloading method and overriding method. There are two different terms, two completely different things. Overloading is when a method has the same name as one or more other methods, but with a different signature. Again, just remember what signature is. It can be the same name but different signature, different parameters, for example. When a method overrides another method, however, they both have the same signature. Overload is different. They have different signature but the same name. Overriding, your method will be overridden when they both have the same signature. So if you do not want override your method, you should use final keyword. The final modifier will prevent the overriding of a superclass method in a subclass. And here's example how you use it. When you create your method, it's public and final keyword void message. And then, for example, you want to print something, whatever your method is. So final instead of static, it's final. If a subclass attempts to override a final method, the compiler generates an error. This ensures that a particular superclass method is used by subclasses rather than a modified version of it. Because if you do not use final keyword, just like I showed you in this example, it will use this version of the method. And this I mean by subclass. But if you wanted to use superclass, you need to use final keyword. And let's talk a little bit about protected members. Protected members of a class. So we already know private and public, and now it's time to take a look at protected members. Protected members of a class may be accessed by methods in a subclass and by methods in the same package as the class. Java provides a third access specification, protected. A protected member access is somewhere between private and public. And for now, I just ask you to understand it, just in theory. I'm not asking you to use it right now. You will see more of it in when you transfer to some university. It's going to be your fourth Java class. So for now, you just have to understand. You just need to know this, but I'm not asking you to use it again. So using protected instead of private makes some tasks easier. However, any class that is derived from the class or is in the same package has unrestricted access to the protected member. It is always better to make all fields private and then provide public methods for accessing those fields. It's a suggestion, okay? If no access specifier for a class member is provided, the class member is given package access by default. And this, again, package, you don't need to know. It's just good to know it exists. Any method in the same package may access the member. And here you can see a table. When no modifier specified, it's accessible to a subclass inside the same package. Yes, and so does public and protected, but not private. Private not accessible. And here you can see what accessible to all other classes. Everything but private again. And this table, the next table, shows us if it's accessible to a subclass outside of the package and all other classes outside of the package. And default, which is no modifier specified, is not accessible. Public, yes and yes, and protected and private, protected accessible to a subclass, but it's not accessible to all other classes. And private is not accessible to anything. And let's take a look at chain of inheritance. A superclass can also be derived from another class. And in this case, it's object class. You remember everything derived from object class. On this slide, you can see graphical representation of inheritance, and that's how we represent it, how we draw it in Java. Here's your subclass or superclass. Sorry, it's your superclass graded activity, which has two children, final exam and pass-fail activity. They both are derived from superclass. And here's another class, which is extended from pass-fail activity class. So it's not extended from graded activity, it's extended from pass-fail activity class. All Java classes are directly or indirectly derived from a class named object, and we just saw it a couple slides ago. Object is a part of the Java Lang package. Any class that does not specify the extend keyword is automatically derived from the object class. That's what you just need to know, but you do not use it now. So now if you want to extend something, just do not extend from some object class. You don't need it so far. Because every class is directly or indirectly derived from the object class, every class inherits the object class members. Example, toString and equals. They are built-in methods. You can say this. In the object class, the toString method returns a string containing the object's class name and the hash of its memory address. And now please pay attention, and of course I will show you this in my code example. ToString, that's something you are going to use probably every time you work with objects. And equals also is very helpful. The equals method accepts the address of an object as its argument and returns true if it's the same as the calling object's address. And you can see those examples in book, and of course I'm going to show you one right now. Let's write some class, some parent class with some child class. On this slide, you can see graphical representation of inheritance, and that's how we represent it, how we draw it in Java. Here's your subclass or superclass. Sorry, it's your superclass graded activity, which has two children, final exam and pass-fail activity. They both are derived from superclass. And here's another class which is extended from pass-fail activity class. So it's not extended from graded activity, it's extended from pass-fail activity class. All Java classes are directly or indirectly derived from a class named object, and we just saw it a couple slides ago. Object is a part of the Java Lang package. Any class that does not specify the extend keyword is automatically derived from the object class. That's what you just need to know, but you do not use it now. So now if you want to extend something, just do not extend from some object class. You don't need it so far. Because every class is directly or indirectly derived from the object class, every class inherits the object class members. Example, toString and equals. They are built-in methods. You can say this. In the object class, the toString method returns a string containing the object's class name and the hash of its memory address. And now please pay attention, and of course I will show you this in my code example. ToString, that's something you are going to use probably every time you work with objects. And equals also is very helpful. The equals method accepts the address of an object as its argument and returns true if it's the same as the calling object's address. And you can see those examples in book, and of course I'm going to show you one right now. Let's write some class, some parent class with some child class. Now let's write class public class bicycle, which has two fields. Let's do public integer gear and public integer, let's say, speed. Those are two fields of this class. Two fields and one constructor. Public bicycle, and constructor takes those parameters, those fields, just here, and integer speed. So this gear is gear, and this speed is speed. Now let's write some methods. Three methods. Public void apply break. So it's just example, it doesn't do anything like real, but let's say I want to decrement speed of the bicycle. Decrement, and how do we decrement? Just speed minus equals decrement. Oops. So basically what's doing, it's taking a speed and reduces by number which I specify as a parameter. Yeah, we will call it apply break. And let's do another method, which is public void speed up, which will take parameter integer increment, and what's going to do, it's taking a break and adds to the break this number. So basically updates speed. And another method will be toString to print info of bicycle. So public string, because it's going to return string, and name of the method is toString. And we just return some string. Let's say number of gears are gear plus, just for new line, oops, let's do this, plus speed bicycle is plus speed. That's our toString method. And that's it for this class. It's our bicycle class, just general class or subclass. I mean superclass. Superclass parent or parent class. Now let's create typo. Let's create another class which will inherit something from the parent. So let's, in other words, let's extend this class. And for this, I'm going to write derived class, which is also public class. Let's do mountain bike. Mountain bike. And now we use extends keyword and name of the class which we want to extend. And we want to extend bicycle. So that's your class header. That's how you create a class, a subclass or child class. Let me put it here, subclass, derived class. So instead of having just public class, some mountain bike, you will extend, you can see it's blue, it's keyword and name of the class which you want to extend. And let's say we want one more field. So this class adds one more field. It can be many fields, it can be any number of fields, but I'm going to use public again, integer, sit height for the field, and one constructor. It has to be constructor. So it's not going to inherit constructor by itself. You still need to write some constructor. And if you want to use constructor of your parent class, you will use super class. You will use super keyword. But let's see how it works. First, I'm going to create constructor public mountain bike with parameters. So let's think about parameters. Of course, it has, since we extend, it has the same parameters as our parent class has, or superclass. So it should be in the same order. I just copy this so you can see in gear, in speed. And now I have one more field, this one. So I'm going to add it to my parameter. This is my constructor, but I need to invoke super class bicycle parameter, or not parameter, constructor. You remember in the lecture I told you if you want to use this constructor you need to call superclass. And superclass, how do we do this? It's just super keyword, parentheses. Inside parentheses, you specify parameters of this class, of this constructor, of your superclass constructor. If you go here, you can see int gear and int speed. So when you call this constructor, you need to use super keyword and its parameters. Of course, semicolon. But we still have one more parameter, which is height. So we need to have it in the constructor as well. And in superclass, if you see the constructor, it doesn't have any height, right? It's only for mountain bike. So this seat height equals seat height. And again, it is just an example. If you see your code doesn't really do anything, I mean it does something, but it's void. We do not return anything and we don't print it, so just as an example. So we have this constructor. We are done with constructor, and now let's create one more method. This class adds one more method. So this is unique method. Your superclass doesn't have this method. So this is public void. And let's do set height setter, which takes integer sh as a parameter, and this is going to be just a regular setter. This seat height is sh. And now let's override toString method of bicycle to print more info. So the reason is in our super class, which is bicycle class, we have toString method which returns a string. But this time we have something else. We have height right now, and what we want to do, we want to be this in the string. That's why we want to override this method. And you can override actually any method you want. You remember? So public string toString, no parameters. So how do we override it? Return, because remember you want to return some string here, right? So now super keyword, just like I showed you here, super dot and name of the method which you want to override, which is toString method, plus seat height, and that's it. So this guy will give us everything from this method, which is gear and speed. But we also have height, and we want it to be in our string. So toString plus name of your field, right? Let me do just one more thing for better readability. So it would be more readable if I started with new line. And now we can go to, hold on, sorry. Now we can go and create our tester class. Remember your bicycle class and mountain bike, they do not have any main methods. It's just for your object. It's just your objects. So let's now create tester class. So public class, I'm going to name it bicycle tester. I will do it bicycles tester. So this is a tester for what we just wrote. Of course, our each tester class is going to have main method. Other way, it's just not going to print anything. We're just not going to test it. Main string args. And now we need to create an instance of a mountain bike because that's the one I want to test. So it's the name of your object, which is mountain bike, and name, I will name it just MB equals new mountain bike, which is name of your object or your class, and parameters. So which parameters we are going to use? Let's see. Here's our constructor: mountain bike, integer gear, speed, and height. So for gear, I'm going to use 3. For speed, I'm going to use 100. And for height, I'm going to use 25. So remember, you need to follow the order of your constructor of your parameters. So we are done with creating an instance. Now let's just test some method, and I'm going to test print line. I'm going to test this toString method. So name of my instance, then dot name of the method, which is toString, and that's it. So we compile it. Okay, bicycle. We compile it, and here I have some typo. We run it, and it's giving us number of gears are 3, speed of bicycle is 100, and seat height is 25. I should change it to is. It would be more correct. What if I want to test my bicycle object? What would I do? I would create bicycle. So I hope you noticed what we got those two guys from bicycle class. because it's here. It's here, right here. And height we got from mountain bike class. If you take a look, there is no gears and bicycle created, right? I don't have this field, those fields, and I have it in my constructor, which is gear and speed, but how do I use it? I call my super constructor of superclass with those parameters. But just for fun, let's test our bicycle just for comparison. So new bicycle with parameters, let's say 3 and 100. Just speed and number of gear. So how can I test it? Let's test it here. It's going to be very similar, but this time I'm going to use B, which is bicycle, to string method. Compile, run it, and you can see it only gives me gears and speed. But there's no point. It was just for example. That's what you were interested in. You call in this class, you testing only mountain bike class, but you get the entire info. So that's it for this lecture. Just let me know if you have any questions. You can message me, you can email me. And next week we are going to have office hours, collective office hours. I really hope you can join.